Right now, we're inside a computer program. At least, that's one hypothesis. Is it really so hard to believe? Elegant experiments with entangled light have revealed a startling discovery at the heart of physics. Nobel Prize-winning research suggests that the universe is not locally real. But what does that mean exactly? Real means that objects have definite properties independent of observation. For example, the moon remains in orbit around the Earth even when no one is looking. Local means that objects can only be influenced by their immediate surroundings, and that no influence can travel faster than the speed of light. Investigations at the frontiers of quantum physics indicate that these conditions, locality and realism, cannot both hold true. This revelation has led some people to connect the dots with the so-called simulation hypothesis. Philosopher Nick Bostrom proposes a fascinating argument about the possibility that our entire reality is a computer simulation, much like the one depicted in The Matrix. He suggests that one day we might build extremely powerful supercomputers capable of creating simulated universes teeming with sentient beings who have no idea that they exist inside a simulation. Bostrom's reasoning can be simplified as follows. Once you have the technology to create simulated universes, it becomes vastly easier to produce countless simulated realities than to produce a single real one. Real universes are hard to form, maybe only one or a few exist, while simulated universes could be created in enormous abundance. If that's the case, then statistically speaking, it's far more likely that we ourselves are living inside a simulation rather than in a base-level reality. The simulation hypothesis states that our entire existence is a simulated reality. Bostrom outlines that one of three possibilities must be true. 1. Almost all civilizations at our current stage of technological development go extinct before they become technologically mature. 2. Almost all technologically mature civilizations lose interest in creating ancestor simulations, detailed recreations of their historical predecessors. 3. We are almost certainly living in a computer simulation. While we can't determine which one of these three scenarios is correct, the argument shows that at least one must be true. This might sound even more radical than some multiverse theories, yet in another sense, it's less so, because it doesn't rely on unknown physics. It only assumes that much more powerful computers can exist in the future. If the first two options are false, that is, if some civilizations do reach technological maturity and remain interested in running simulations, then they could create astronomical numbers of simulated universes. A technologically mature civilization's computing power would be so immense that simulating an entire human history would require only a minuscule fraction of its resources. Thus, there would be many more simulated realities than original histories. In that case, most beings with experiences like ours would be in simulations, making it highly probable that we too are simulated. However, Bostrom's argument does not provide evidence that we are in a simulation. It only posits a logical framework. Critics rightly point out that proponents of the simulation hypothesis have yet to offer any concrete proof. Moreover, there are competing ideas. For example, the fine-tuning problem, which asks why the fundamental constants of our universe are so exquisitely set for life, has long been used by religious thinkers to argue for a creator. Some supporters of the simulation hypothesis use the same fine-tuning as evidence of a designer, albeit a programmer. Others prefer the multiverse hypothesis, which holds that numerous universes exist with varying constants, and naturally, we find ourselves in the one suitable for life. One reason to consider a model like the multiverse is that it elegantly addresses the fine-tuning problem without invoking a deity or a programmer. If a vast ensemble of universes exists, each with different constants, then observers will only arise in those universes where the conditions support life. Thus, it's no surprise we observe a universe fine-tuned for our existence. In conclusion, the simulation argument presents a striking trilemma. Either advanced civilizations never reach technological maturity, they reach it but find no interest in simulating their ancestors, or we're almost certainly inside a simulation. While we currently lack the means to confirm which scenario is true, it's a thought-provoking puzzle. Even if we were living in a simulation, our best bet for understanding what happens next is to continue studying the patterns of our reality, simulated or not, and act accordingly. Thanks for watching. Did you enjoy this video? Show your support by subscribing and ringing the bell so you never miss more content like this.